Hi, fifth graders. Today I want to start off our video a little bit differently, and that is I don't want to jump right into the math just yet because I want you to consider this scenario. Let's say that you're walking down the hallway with a bathroom at either end of the hall. I know, kind of a silly way to start a video, but hang with me. So you're in this hallway and there's a bathroom at both ends. Let's say, for argument's sake, that you're walking down the hall from the left to the right. Now imagine that you are at point A. Which restroom do you use? So let's say this is point A and this is you walking down the hall. Yeah, you're probably going to use the restroom that's right behind you because you're really close to that particular restroom. Well, what about if you're at point B? Now which restroom do you use? All right, so you're probably going to use the one that's just a little bit ahead of you because that's closest to where you're at. But what about if you're exactly in the middle of the hallway? Now, you've already walked halfway down the hallway towards wherever you're going. Does it make sense to go all the way back to this bathroom just to have to go back to this middle point again? Or should you just keep going to this next bathroom because you're headed in that direction anyway? Yeah, I would just keep going forward because I'm headed in that direction anyway. All right, I have a confession to make. This isn't really a scenario I needed you to consider for a non-math reason. This is actually an example of real-world rounding. So all along in your math career, you've been taught that rhyme, 4 or less, let it rest, 5 or more, let it soar. And what that meant was that if your number ended in 0, 1, 2, 3, or 4, you would round down to the lower value. And if your number ended in 5, 6, 7, 8, or 9, you would round up to the higher value. But this example is y, and that middle point is the one that we really have to decide about. So that's why 5 gets rounded up, because you're already headed in that direction, so it makes most sense to round up to the next amount. Let's take that and apply it to rounding some decimal numbers. So thinking about the restroom example, I'm now going to change that hallway into a number line. So if I have 0 and 1 as my endpoints on my number line, and I put 1/10, 2/10, 3/10, all the way up to 9/10 on my number line, that means that I would round 1/10, 2/10, 3/10, or 4/10 down to 0. And I very clearly know that I would need to round 6/10, 7/10, 8/10, or 9/10 up to 1. But I'm also going to round 0 and 5/10 up to 1, even though it's exactly in the middle and exactly the same number of spaces away from 0 as it is from 1. That restroom example helps me understand that I'll round that number up. All right, so let's put that into practice. Let's say I want to round 14 and 627 thousandths to the nearest tenth. Well, in order to do that, I'm going to find the digit in the place that I'm rounding to first and circle it or underline it. So I have the number 14 and 627 thousandths, and my problem tells me to round to the nearest tenth. Well, I know that the digit 6 is in the tenths place, so I'll circle that, or you can underline it on your paper. Then I need to look to the digit directly to the right and use my rounding rules. So if I'm looking directly to the right, that means I'm going to use that 2. Since 2 is a digit that tells me to round down, I know I'm going to keep this 6 as a 6. Finally, I'll rewrite my new rounded number, and the most important thing to remember is I need to drop any of the digits after the place I'm rounding to. In other words, I would round this number to 14 and 6/10. It's important that I drop the 2 and the 7 because the problem wants me to round to the nearest tenth. That means I need to stop in the tenths place. Let's take a look at another example. This time I want to round 8 and 595 thousandths to the nearest hundredth. So again, I'll find the digit in the hundredths place. I know it's the hundredths place for this number because it tells me that right in the question. In this particular number, the digit 9 is in the hundredths place. Then I'm going to look to the digit directly to the right and use my rounding rules. The digit 5 is directly to the right. I know that 5 is going to round up, which means I need to bump this 9 up to a 10. Just like with whole numbers, if you bump a 9 up to a 10, we are also going to need to change another place. In this case, we also need to change the 10th place digit as well. So now I'll rewrite my new rounded number. So 8 and 595 thousandths rounded to the nearest hundredth would become 8 and 60 hundredths. Let's take a look at one more example. This time I want to round 17 and 341 thousandths to the nearest whole number. So I will find the digit in the place that I'm rounding to and circle or underline it. But uh-oh, I don't see a place value name here. Instead, it tells me to round to the nearest whole number. Anytime you're asked to round to the nearest whole number or nearest whole unit, it's talking about the ones place. So in this particular number, I know the digit 7 is in the ones place. Now I can use those rounding rules to help me. So I'll look to the digit directly to the right, which is a 3. Since a 3 tells me that I need to round down, that means I can rewrite my number rounded to the nearest whole number as 17. And you can write that with the decimal point at the end or without it. So hopefully this gave you a little bit more of an understanding of your rounding rules and helped you learn how to round decimals. Remember, the most important thing to keep in mind is that you are dropping all of the digits after the place value position you've rounded to. Thanks for watching, and I can't wait to work with you guys on this more soon.